Today we're going to try to investigate and see what a redox reaction might actually look like. Now we did a little bit of reading about rust before, so we're going to see if we can simulate that. Now first, what I'm going to need is I'm going to need my nails. Now your typical nails that you get from the hardware store are galvanized, which means that they have zinc plated around them. So this won't work exactly, but if you get one of those cheap old rusty nails like you see here, I have actually scratched the rust off of them, so they're I've got iron in them, and you can see they are magnetic, so they do have iron. Anything that is magnetic, magnetic like this, is either iron, cobalt, or nickel. So pretty good bet that these are iron. So right now I've got my iron that is my nail that is iron. I'm going to use some copper sulfate, and then I'm going to use salt. Now remember in our reading, salt is going to be our electrolyte. Now, so the first thing I'm going to do is I'm going to take some cotton balls, and I'm going to soak them in water, just spray them down. Now these are actually not cotton balls, they're nylon, but they'll work the same. They're just trying to make a barrier so that the salt and the copper chloride don't actually touch each other, but they're going to make solutions eventually, because you'll see. And so they're going to be wet. So now the thing on the bottom is I'm going to put about, procedure says to put about 2 centimeters of copper sulfate on the bottom. So that's about an inch. Yeah, 2.5 centimeters is an inch. So something like that. Okay? Not a lot, but enough. Okay? And then it says to fill it with water up until it gets to the top, and then I'm going to take one cotton ball and stick that one in there. Ooh, it makes a cool sound. And so my nylon ball or cotton ball is stuck in there. Maybe an experiment you could do at home if you have copper sulfate. And so just make sure there's water enough into it. Alright, there's enough. A wet spatula in my pure sodium chloride or my pure salt would not do well. So, as you can tell, the salt likes to stick to the outside because it is wet in there. I'm going to put about another 2 centimeters, which is about 3 scoops. It's very non-quantitative. And then I'm going to spray water on the outside to try to get all that sticky stuff off. Okay. And voila, we should be good. So now we have a barrier between the copper chloride, we have the cotton ball or the nylon, and then we have our salt in the middle. It's very salty. And then we'll put another piece of copper chloride in there. And we're going to push that down all the way down to the bottom. So now the solid substances, even though they may not stay solid, are now not touching each other. Okay. And then the last piece is the copper is not really, by itself it might be fine. Let's see if we'll take some iron, and we're going to put these on top. So let's go ahead and put 3 nails in there and stick those in there. And one of them is bigger than the other. That's alright. We'll get those in there, and they're going to be right on top. Now before we close it, we're going to add water all the way up to cover the nails. And these are your initial observations. Now what you should be thinking of is something on the particle level. Remember, that's like kind of what we're trying to get to. Remember this solid right here, this iron is a solid, so all the particles are really close together, really tightly packed. And now this copper sulfate eventually is supposed to dissolve, right? And it'll make this blue solution. So what would that look like on the particle level? Remember, those copper ions now are going to be floating around in solution. Now that electrolyte, what's that going to do? Well, maybe it will help conduct the charge. So we're going to let that sit. It's not going to happen immediately, but after maybe a day or so, we'll take a look and see our observations at the end. Before you actually make before you take a look at the next one, try to make a prediction. What is going to happen? Based on what you know between copper and iron, look at that activity series, see how those two are going to react with each other, which one is more macho, which one is more reactive, and which one is going to end up being an ion in the end. Okay? All right. Okay, so in handout 4.4a, in your workbooks, we can take a look at just a few things. So our observations of the nail. Let's hopefully you saw that it was a shiny metal, and say the rust was scraped off. So that is, and let's say that it was a silver color. Okay. Now, if I just said it was silver, then silver is an element. So that's not specific enough. Let's say we could call it a silver color. That would be acceptable. So the solution, that would be the copper solution, as I added water to it. Let's say it was a deep blue or a bright blue color. Let's see if we can specify what type of blue. Was it navy? Was it a deep blue? A bright blue or a deep blue or a navy blue or light or something like that. Let's see what else. I can't really find too many other things. Let's just move on. So with number 2, the nail is made of iron. Below, create a particulate representation of the iron atoms in the nail. So if we zoomed in to the particle level, what would the atoms look like? Now you should say that all the atoms are locked together as a solid, like so. I probably drew too many circles. And something like that. That would be helpful. So it just acts as a solid. Now for number 3, the solution of copper 2 sulfate. Below, a particulate representation, create a particulate representation of the copper 2 sulfate solution. You do not have to include the water molecules. So most of this is water that is floating around, but this is your copper 2 sulfate. So you have some copper, and you could write ++ on there to represent the copper ones. Let's say, let's make a circle and we'll write ++, and that would be copper 2+. And then your sulfates are actually going to be larger, and they are going to be -, and those are SO4s, 2-. So what you would need to know is that because copper sulfate, there is 1 copper for every 1 sulfate. So for every copper that you draw, ++, you need to draw the same number of sulfates. Let's draw one more, and let's just put it right here, ++, and then -. So big things to notice here are that, remember, the positive ion was smaller because, remember, cations are smaller, tiny cats, and then we think of monster ants. This is the anion. The anion is much larger. We remember that as it gains electrons, the electron field is going to get larger. So those would be tiny little idiosyncrasies you would be gaining or losing points for. So now when we take a look on the next page, pretty simple. Number 4, how many protons and electrons are in each iron atom in the nail? Let's see, so we look at iron, and we look at our friendly periodic table, and we see that the atomic number is 26. So that means that there are 26 protons, and we'll write a plus up there to indicate that they're positively charged. And since the oxidation state was 0, meaning its charge was 0, iron is a solid, that means that there were 26 electrons. Okay, that is a neutral charge. Now the protons and electrons that are in each copper 2 ion of a solution, so this is copper 2 plus, remember that oxidation state is 2 plus, and that is aqueous. So let's find copper here. And now copper's atomic number is 29. So that means that there are 29 protons. Now it has a positive 2 charge. So I'm not going to add 2 electrons. I'm actually going to take away 2 electrons. So there are 27 electrons there. That means that I have 2 extra positive charges than my negative charges, right? So if I added 29 plus a negative 27, I would end up with a positive 2. Okay, hopefully we're following that. Now, just below the diagram is a diagram of a demonstration setup, just to make sure you understood that the iron was on top. You add some cotton here or nylon, and then sodium chloride, and then your cotton, and then your copper sulfate. Now this was as a solid. And then sodium chloride was a solid, and then iron was a solid as well. They were all solid, and then the whole thing was filled from here to here with H2O, with water, and that was all liquid. And then the last one, number 7, is for you to do on your own. Make a prediction about what will occur when the iron nail is placed in the test tube. Containing the copper 2 sulfate solution overnight. Now, you're supposed to be looking at your activity series here. Let's take a look at the iron, and let's take a look at our copper here. So if we condense this activity series, we should find that iron is more reactive than copper. So hopefully you understand. We've been watching the activity series, and we understand that the one on top is the most reactive and is going to end up being an ion. Okay, I'm here to show you the results for the experiment, and if you will take a look, we have this right here, and it looks pretty cool. Where, let's see if I can get a background on that. And as you can tell, you will see that the bottom part still stays blue. And this part is kind of green. You still have kind of the white electrolyte. Now the iron nails have kind of poked through this cotton. I think that's mostly due to gravity here. And you see some type of orange stuff that's kind of floating in here. If I kind of move it around, it's a solid that is floating around. Okay, kind of like a precipitate. It's not exactly a precipitate. It's more of a solid that's happened. So not exactly what I expected. I expected copper to make it all the way on top of and actually plate the iron, which is actually what you should see when you put a nail into copper sulfate solutions. But this one is really cool and really interesting to see. So now let me throw in one little tidbit here. Your reaction that we obviously saw a chemical reaction. We saw copper 2 plus in the aqueous state, and we had iron as a solid here. Okay, those are the two things we were focusing on. There is a sulfate there, but we're going to omit it. Now what you're finding is that brownish color is going to be your solid, as your copper solid, and we're finding iron probably iron 2 plus as aqueous. Okay, so that rust right there, that iron 2 plus, that's the rust. Okay, if you did your reading, this is the same type of reaction of like the rusting reaction. Okay, remember we added an electrolyte in there, and that's really helpful. So that's kind of what you should be able to see. You should have seen the copper solid. And now the iron 2 plus, this one is actually kind of a brownish orangish color. And so I believe some of that brownish orangish color that's dissolved in solution is partly due to that. And copper we know is also kind of brownish orangish as well. So both of those have similar colors. Now, an interesting thing to note down here is you see that blue and that green? Well, copper in the 2 plus state, it's aqueous, is blue. Copper 2 plus is blue. But copper that is 1 plus is green. Very cool. So you can see that, let me see if I can. So you can see something cool here where you have the copper 2 plus as the at the bottom, and you can see the progression in the copper plus, and you can see the progression in the copper 0. And it looks really cool. I think that's a really neat trick that they added there. And you can see how copper was being reduced going up, and then iron is being oxidized going down.